Hello class, I'm just making a quick video to remind you about your upcoming chemistry and metric exam. Please remember that this is just an estimated breakdown of points. This exam will count for 5% of your grade. Roughly speaking, there will be 4 points that are going to involve the metric conversions that we covered in class as a review. And please understand that the answers that you get will be converted into the scientific notation. All of this will be part of the multiple choice Scantron section. Continuing on with the Scantron multiple choice section will be 2 problems where you convert from scientific notation to standard notation. Next, there will be about 5 concept questions. Please read your lab manual and make sure you understand concepts like molarity, molality, osmolarity, osmolality. Next, you will have about 2 points worth where you're solving for an unknown factor. We've practiced some of these in class. If you know 2 out of these 3 variables, you should be able to rearrange this equation and solve for the unknown third. A similar example would be if you have 4 variables. If you know 3 out of the 4, can you solve for the unknown fourth? And then lastly, on the back of the exam, you will have 6 points worth of written responses. 3 points will be if you're given the grams percent, can you convert to osmolality? And if you're given osmolality, can you convert to grams percent? This will also be worth 3 points. You will be allowed roughly 40 to 45 minutes to take this exam. Many of you have been asking me about the challenge question I gave in class. Most of you did not show me your attempt. That is not okay. You were specifically told to come to me and show me your attempt. A few of you did, and I greatly appreciate that. Your challenge was, what grams percent of sodium chloride would be necessary in order to make a 300 milliosmolal solution? Remember, 300 milliosmolal is our magic number for all of our body fluid compartments. The first part you do to set up this equation is start with what you are given, 300 milliosmolal. That's 300 milliosmoles in a kilogram of solvent, which in this case is water. We know that there are 1,000 milliosmoles per 1 osmole. Because we're playing with sodium chloride, it has a dissociation factor of 2. There would be 2 osmoles for every 1 mole. We know that the molecular weight of sodium chloride is 58.45 grams per mole. And this would give me 9 grams of sodium chloride per kilogram of solvent, which is water. Now I need to convert the kilograms of solvent into 100 milliliters. I'll remind you, grams percent means grams per 100 milliliters. So if I come back down here, I have my 9 grams of sodium chloride in 1 kilogram of solvent. Because we're playing with water, 1 kilogram of water has a volume of 1 liter. And because I want 100 milliliters, I have 0.1 liters, a tenth of a liter, is the same as a deciliter. This gives me 0.9 grams percent. Just to review how I got this conversion factor, follow along right here. A deciliter is 100 milliliters. Let me show you. 1 deciliter converted to milliliters. I jump 2 times to the right. 1, 2. That means I would move my decimal point here 2 places to the right. That would be 100 milliliters, which is what I want. But how does a deciliter compare to a liter? Well, if I move from a deciliter to a liter, that's moving 1 decimal point over to the left, which would be 0.1 liters. So I've just proven to you that 1 deciliter is the same as 100 milliliters, which is what we want when we're computing grams per cent. That means grams per 100 milliliters. And I've just shown you also that a deciliter is 1/10 of a liter. Some common mistakes with this example are: 1. The student doesn't remember their dissociation factors. You were given a list in class and you're expected to know that. Don't forget, glucose and proteins have a dissociation factor of 1, which means they don't dissociate. The next common mistake I see is that the student does a lovely job setting up all of this part of the equation, and then they make this glaring mistake right here. They put down 1 liter is the same as 1,000 milliliters, which is in fact true. However, if you do that calculation, you will end up with a final calculation of grams per milliliter. And that is not the same as grams per cent, which means grams per 100 milliliters. The next common mistake I see is that students forget that this is a 2-paged exam, meaning there's a front and a back. Students forget to turn the exam over and complete the written work on the back of the exam. Don't let that happen to you. That will be 6 points you're automatically missing.